Hey everyone, Mr. Skelton here, back for lesson 3 in unit number 4. We are moving forward with our proofs, our triangle proofs to be specific, and today we're going to talk about two more shortcuts, and they are listed at the top: angle, side, angle, and angle, angle, side. And so you can see the learning targets at the top there. The second one is really the one I want to stress to you. I can prove that two triangles are congruent by any of the shortcuts learned. This was the first one, this was the second one, and today you're going to learn about 3 and 4. So carrying right into that statement, it says yesterday we learned how many shortcuts, or in lesson 3, not maybe yesterday, but in lesson 3, how many shortcuts or in lesson 2, how many shortcuts? We learned 2 shortcuts, and they were side, 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 and side, angle, side. Remember that in side, angle, side, the angle has to be in between the two sides. Give you a quick little review. If there's your angle, that has to be that side and that side. That's side, angle, side there, because the angle is inside. And today you're going to learn about 2 more. First one, we'll call it number 3. Number 3 is angle, side, angle. Now, you can kind of remember angle, side, angle in the sense of side, angle, side, because if 2 angles and the included side of a triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So the same rules apply to side, angle, side as they do for angle, side, angle. Let me just draw you a quick picture of an example of angle, side, angle. Angle, side, angle. The side is included, or remember we said in between the 2 angles. Okay, notice this gets 2 tick marks, right? Because I don't know the angle measures exactly, so just getting used to how some of those look. Okay, so let's look at an example. It says, let me get this in the picture here for you. It says name the 2 triangles that are congruent by this. So you got to pick out the 2 that are actually congruent. So what I'm looking for is 2 angles and a side in between them. And I notice one here, right? Here's a tick mark, and here's your 2 angles, and this one here, side is in between. Notice this one, you have your 2 angles, but this tick mark is here. It's not where it should be, which is right in here. Okay? Now, a congruency statement is just stating the 2 triangles. And again, this is important. So basically, the congruency statement is listing the 2 triangles. And I'm going to name it, and you can name these any different way. Like I'm going to name it ACT. ACT, just like the test you're going to take probably when you're a little older. Now, if I call this triangle ACT, go ahead and tell me, I'm going to put the triangle symbol there, what specific letters do you have to name for this second one here? If I said A, and then C, and then T, this one should be called D, G, O. D, G, O. Now again, I don't have to start at letter A. Heck, I could have said triangle TCA is congruent to, if I said TCA, I'd have to go OGD. Triangle OGD. And if you're still confused on how I'm naming those, or naming those triangles, what I always do is look for the markings, and I try to follow patterns. Like if I started at T, T has nothing, and then it goes to C, which has that little 1 angle mark, and then goes to A. So I go from nothing to a little angle mark. What about this one? Nothing for O, little angle mark to G, and then D, O, G, D. So I look for the markings to kind of help me with the proper naming, okay? All right. The 4th theorem is angle, angle, side. Let me get this in your view here so that you can see it. Cool. So this is number 4, angle, angle, side. And it says if 2 angles and a side. Oops, sorry, because I have that. This is supposed to be non-included side. And let me kind of refresh this. If 2 angles and a non-included side are congruent to 2 angles and a non-included side of another triangle, then the triangles are congruent. Okay? So it says, this question says, how many included sides do two angles have? Kind of a tough question. If you take a look and just draw a picture, it says how many included sides do two angles have? So here's two angles. How many included sides do two angles have? One, right? Right there. How many non-included sides do two angles have? So if you look at these two angles, okay, how many non-included sides do two angles have? Two, okay? So the example says, answer the question using the diagram below. How do we know that PQT is congruent to, this is supposed to be triangle. Oh no, sorry. How do we know angle PQT is congruent to SQR? Look what's in the middle, Q. So here's Q right here. How do we know that these angles are congruent? The answer is vertical angles. Okay? Question number 2 says, which sides would need to be congruent to have angle-side angle congruency? Now, I made a little mistake here.
Hi, Daddy.
Hey, buddy. I'm making a video real quick. Can you give me a second?
Yeah.
Okay. Thank you. Sorry about that. Which sides would need to be congruent to have angle-side angle congruency? So if you look at these two angles here and here, and here and here, we'd need to know these right there, because the side has to be in the middle. Okay, so I'm going to call that PQ, and if I called it PQ, then I need to call this one SQ. Okay. Now I'm using pen. I probably shouldn't have here because I'm going to mark this up. Question 3 says, which sides would need to be congruent to have angle side? Now the nice thing about angle side, and I really didn't talk a lot about it up here, is that this side can be any side except the included side. Okay? Because if it was the included side, then it would have to be angle-side angle. So really you have a choice here when it says which sides would need to be congruent to have angle side. All right, it could be this one, RS and PT, or excuse me, RS and TP. So I'll say RS congruent to TP, or it could have been this side, RQ, okay, or TQ. So RQ congruent to TQ. All right. Now this one says, notice which letter combination is not a congruence theorem. Okay, so we have side, we have side, we have angle, side, angle, and we have angle, side. There's no such thing, I'll write it here, there's no such thing as angle, side. And you can kind of understand, hopefully it's a little kind of a joke, right? Angle, side. There's no such thing. Think of the acronym. All right, you get it. Let's move on. All right. So on the back here is getting into the proofs. And so this is where we're going to spend a majority of our time. These are our 2-column proofs. So here we go. I see there's some markings that are already given to us, and I see a given statement. So I'm going to kind of put this in here. I like to make a nice little T-chart there. So number 1, you can do this any different way. I'm going to show you some variety. I'm going to say angle P is congruent to angle S, and that is given to us because of the markings. Okay. Number 2, I write my given statement. Q is the midpoint of PS, and that's given. Okay. Now, again, what does the given statement lead to? Q is the midpoint of PS. What does that mean? That means these two things have to be congruent to each other. If Q is in the middle of P to S, then I know PQ has to be congruent to SQ. So I'm going to say PQ is congruent to SQ. And the reason I can say that is definition of a midpoint. Okay? Number 4, the other thing I know just by looking at the picture is I have vertical angles here and here. Okay, so I need to name those. So I'm going to say angle PQT is congruent to angle SQR, and that is vertical angle theorem. Okay? Now I have an angle equal to an angle, I have a side congruent to a side, and I have an angle congruent to an angle. Now that's just a kind of a checklist for me. The order of these do not matter. What matters is what's on your picture. And I have an angle with a side in between the other congruent angle. So I know that these two triangles, which is right here, my last statement, triangle PTQ is congruent to triangle SRQ, and the reason is angle, side, angle. Okay? So that's not a bad one. That's kind of a, put difficulty level 2 to 3 there. So moving on to example number 2. All right, I'm going to make my T-chart there. Okay, here we go. Given RN bisects angle MNP, and then it's got another statement. So this one has two given statements in it. Okay. It also says angle M is congruent to angle P. So for both of these, you get the old given. All right, and I'm going to actually mark angle M with a single tick mark, with angle P single tick mark. Now, RN bisects angle MNP. Where is that angle? MNP, that's up here. And RN is bisecting. Remember, bisect means to cut in half perfectly. So if it's in cutting an angle in half, I get two equal angles, right? So what I have there is angle MNR, which is this one, is congruent to angle PNR. And the reason I can say that is always based on the given information. What is happening? RN is a angle bisector. So definition of an angle bisector. Okay? So I have an angle equal to an angle there, an angle equal to an angle there. What else do I have? Well, this is one of those situations where you have two triangles that are sharing a side. They share NR. So I know NR has to be congruent to itself, and that's the reflexive property. Okay? So there's a side equal to a side. Now look at your picture. What shortcut do you have? You have two angles and a side. Now is that side in between your two angles? That's what you have to ask yourself. The answer is no. So that means that these two triangles, triangle MNR, which I'm done here, I'm putting my proof statement in there, is congruent to triangle PNR by angle, angle, side. Okay? Going on to the last one. I know I'm moving fast, but you can always press rewind and watch them again. Now this is a tough one. What do you notice right away? Parallel lines. Alert, alert, alert. Parallel lines. AIAs probably coming into play here. Probably. Let's take a look at what we got. This is what we're trying to prove. There's actually nothing with the given information. Okay? So let's just write down what we have based on markings. I have angle F is congruent to angle H. And I'm going to put given. Those are the markings. And usually, and I'm going to write this down, even though you wouldn't have to on this one, I'm actually going to put FG, segment or line FG, is parallel to JH. And again, I know that because of the arrows, so I'm going to put given in markings. Not necessary in here because of the picture, but I'm going to write it in there. I like to be very detailed in my proofs, right? That's what proofs are all about being very detailed. Now, let's look at something that students see a lot. A lot of students see this triangle here and this triangle here. Triangle 1, triangle 2. You're trying to show that those two are equal. Do they share a side? It's just like number 2 where they share that side. So most students go right away to JG. And I could have called it GJ. Again, that doesn't really matter. That's the reflexive property. Okay. So kind of backtracking a little bit. I have an angle equal to an angle. Check. This is not a congruency statement. I just said that they're parallel. So don't put side equal to a side because it doesn't say equal to a side. It just says that they're parallel. This one says they're congruent. Okay. And now we got to find something else, right, to complete our shortcuts. Because I only have 2 things listed. Remember, you only need 3 parts. for the shortcut to work. You have parallel lines. I promise you, when you see parallel lines on a triangle proof, you got to be thinking AIA. So where are your alternate interior angles? First of all, let me put this marking here for statement 3, JG equal to JG. I need to mark that. You should always mark your statements on your picture so that you can see things. Okay. Now, this takes a little bit of practice, but I know that this line is parallel to this line, and here's your transversal. Okay. So I have this angle, gets 2 tick marks. I'm giving it 2 tick marks because that already has taken the place of the 1 tick mark, and I got to differentiate between the two and that one. I know that those two angles, I'm going to call it FGJ, angle FGJ is congruent to HJG. Why? How do you know that those two angles are congruent? Look at them. You know because they are alternate interior angles. Okay? So, that's an angle equal to an angle. I'm done. I can do my proof statement. FGJ congruent to triangle HJG. What shortcut? Look at your picture. What markings do you have? Angle, angle, side. Angle, angle, side. Is this side in between your two angles? It's not. So that is angle, angle, side. Okay? Proofs. We're getting going. All right? That's a tough one. But again, you'll start to see some patterns start to form over time with these triangle proofs, and hopefully you just get practice. But your proof should look a lot like mine. Just a couple reminders. Make sure you're numbering your statements and your reasons. Make sure whatever markings or whatever statements you write, you make the markings on the picture. Always look at your given information. Look at your given information and see what you can get out of it. What comes from this? That usually leads to a lot of good things. Okay? Again, I'm sure you'll have questions. We'll keep working on them together.